Okay, so for video 2.3, we're going to continue talking about soil formation and taxonomy, and specifically we're going to look at the idea of intergrading, which is soils transitioning between suborders. And the way we do this, I'm going to draw a topo sequence, and I'm going to change my pen color a couple times here. So we're going to draw a horizon. And what you notice here is that this horizon changes into a wetland on this side. So this is water. And there's going to be a water table in their soil. So we're going to look at three different soil profiles here. Oops. And we're going to see how these change based on changes in vegetation So changes in vegetation equals a biosequence. And we're also going to look at relief changes, and that is equal to a topo sequence. And so the idea is that we're in Edmonton, about 100-kilometer radius around Edmonton, so that we're holding all those other features the same. So climate, time, and in this case, parent material are the same. And so what we might find on a site like this is grassland changing into parklands, aspen parkland, changing into maybe some cattails or bulrushes over here. And sedges on the edge of a wetland. So this is our changing vegetation over this this biosequence, where we're going from grasses to aspen dominated to wetland dominated type species. And there's a slight relief change here too, where there's a general slope down to water, to a wetland or an open pond, and we have a water table. But I'm going to suggest that this water table is greater than 50 centimeters below the surface. And so we'll look at the sequence of soils here. So what we find is an AH, an AE, BT, versus over here, maybe just an AE and a B. Okay, sorry about that. I lost the video right at the end of that. So I recreated the drawing, and I'm just going to start over. So if we look out here, that the soil in this grassland transitional area has an AH horizon, an AE, a BT, and a C horizon. Then we have an AE, a BT, and a C horizon. And over here we have an AE, a BT, a BG, and a CG, because we're starting to get close to this water table. There's some fluctuating water tables, but again, it's below 50 centimeters. So what we can look at is the order, the great group, and the subgroup for these soils. And what we find is that these are all luvisols, because the BT horizon is the diagnostic horizon in all of them. So this AH is not deep enough to be Chernozemic, so it's not a Chernozem, and this BG is below 50 centimeters, so it's not a glycol. So all of these are luvisols. And the order, that's the order. The great group is gray. These are all in Alberta, and we only have one great group here. And it's gray because the dominant process is this movement of clay, and these soils have this typically gray color. But the subgroups differ here. So the orthic subgroup is this one in the middle under the aspen stand, where we have an AE horizon, a BT, and a C. This soil, luvisol, is dominated by clay translocation into the BT horizon, has a diagnostic BT horizon, and the great group is gray. And so this soil adheres to the central concept of the great group, which is AE, BT, C. So this one is orthic. However, out here, as we move this way, soil is getting a little bit drier. Out here, that's why we have grasses, and because we have grasses, we have the development of this AH horizon, and so it's not a Chernozemic AH because it's not deep enough or doesn't have enough base saturation. So it's still a luvisol, but now it becomes, the subgroup is dark. It's a dark gray luvisol. And the dark, so this is integrating towards a Chernozemic order, but doesn't meet all the definition of a Chernozem, so it's a dark gray luvisol. Versus when we move this way, we're getting a little bit wetter, because we're getting closer to this wetland over here. We're getting closer to this wetland and the water table, and so this is this sort of fluctuating water table causing this glaying conditions in a BG and CG. So this is, the subgroup here is a glade gray luvisol. And so that's integrating. So on the one hand, we have our orthic gray luvisol integrating. When it gets a little bit drier here in the effective vegetation, there's a bit of an AH horizon. We get a dark gray luvisol. Or when it gets wetter, due to topographic changes, it gets a bit wetter, we get a glade gray luvisol because we have a slightly different horizon sequence. So this AEBTC is the horizon sequence of an orthic gray luvisol. And once we add this AEBT, we get a dark gray luvisol. And if we have an AEBT-BG-CG, we get a glade gray luvisol. So that is the idea of intergrading at the subgroup level. And we're going to spend some time in lab this week looking at a lot of different monoliths and looking at how soils within an order intergrade towards other orders.